Good day, learners! Welcome to Math Corner's General Mathematics for Senior High School, Episode 6, entitled Evaluating Composite Functions. In this video, I'm gonna teach you how to evaluate composite functions. In my previous video, I already taught you what is composite functions and how to simplify composite functions, where we use the other function as the input of the other function. Now in this video, I'm gonna teach you how to evaluate functions considering that our input are real numbers. Are you ready? Let's get started. Consider example number 1. Given f of t is equal to t squared minus t and h of x is equal to 3x plus 2. Solve for f of h of 1. Now in this example, we are going to solve first for the inside expression, which is h of 1. Now, we are going to use the function h of x to solve for this. We are going to solve for h of x, the function h at 1, which is 1 as the input of the function h. That means we have here h of x is equal to 3x plus 2. And then substitute x with 1. We have h of 1 is equal to 3 times. Substitute x with 1, we have 3 times 1 plus 2. And then simplify. So we have here 3 plus 2, which is equal to 5. Therefore, our function h of x, considering that our input is 1, is equal to 5. Now, what's next here? We can now solve for the function f. The function f, considering that our input is 5. So let us copy function f. Solve for f of 5. Okay, so we have here f of x is equal to, or f of t is equal to t squared minus t. Substitute t with 5. So we have f of 5 is equal to 5 squared minus 5. That is equal to 25 minus 5, which is equal to 20. Therefore, the value of f of h of 1 is equal to 20. Let's take a look with the example number 2. Given f of x is equal to 2x squared plus 1 and g of x is equal to 3x plus 5. Solve for f of g of 2. Now, just like from the previous example, we are going to solve first for the inner function, which is g of 2. That means we are going to evaluate first the function g, considering that our input is 2. That means we have g of x is equal to 3x plus 5, going back to our given, and then we are going to substitute x with positive 2. So we have g of 2 is equal to 3 times, replace x with 2 plus 5. Then simplify. That means 3 times 2 is 6 plus 5, which is equal to 11. Therefore, the value of our g of x at 2 is equal to 11. Since we already have the value of this function g of 2, which is 11, we can now solve for our function f. So we have here, solve for f of 11. That means going back to our given f of x, that is f of x is equal to 2x squared plus 1. That means we are going to replace x with 11. So we have f of 11 is equal to 2 times replace x with 11. That is 11 squared plus 1. And then simplify. So we have 2 times 11 squared. That is 121 plus 1, which is equal to 2 times 121, that is 242, plus 1, which is equal to 243. Which means that 243 is the value of our function f of g of 2. Okay. Let's have the last example. given f of x is equal to x cubed plus 1 and g of x is equal to cube root of x minus 1. Solve for f composed with g of 2. Now, just like from the previous example, we are going to solve first for the inner function. But here, the given function is f composed with g of 2. That means we are going to write first the equivalent function for this, which is equal to f of g of 2. That means we are going to solve first for the inner function, which is g of 2. So going back to our given, we have here the g of x is equal to the cube root of x minus 1. So we are going to replace x with 2, which is g of 2 is equal to the cube root of 2 minus 1, which is equal to the cube root of 2 minus 1 is 1. And then cube root of 1 is also 1. So therefore, the value of the g of 2 is positive 1. Now, we can now solve for, that means we can now solve for the value of our function f. That means solve for f of positive 1. So going back to our given function f of x, which is f of x is equal to x cubed plus 1, replace x with 1, so we have f of 1 is equal to 1 cubed plus 1, which is equal to 1 cubed is 1, 1 plus 1, which is equal to 2. Therefore, the value of our function f composed with g of 2 or f of g of 2 is equal to positive 2.